Hi everyone, here is the review video for section 8-6, which is solving quadratic equations by factoring. Again, you did some of different videos last week as well as activities and IXL skills that use this property. The property is known as the zero product property. And what this property says is if the product of two quantities is equal to zero, then at least one of those quantities has to be equal to zero. So algebraically, what that means is if A times B equals zero, then either A is zero or B is zero. We use this concept to help us solve quadratics that are already factored or that can be factored. So basically you factor the quadratic and then you just set each of those factors equal to zero and solve. Just a little side note, if there are two roots, that should say roots, not root. If there are two roots, the axis of symmetry is actually the mean or the average of those two numbers because it's halfway in between where those two numbers would be. If there's only one root, then the axis of symmetry is at that x value. So for example, we have x minus 3 times x plus 7 is equal to 0. This quadratic is already in factored form, and it's already set equal to 0. So what that means is we just have to take the yellow factor, set it equal to 0 and solve, and then do the green factor, set it equal to 0 and also solve. If we look at the yellow factor first, it's x minus 3 is equal to 0, which would mean that x is equal to positive 3. And if we look at the green factor, it's x plus 7. So we set that equal to 0. And if we solve that, x plus 7 is equal to 0 means that x is equal to negative 7. Just let me try to find where that point is. There we go. X is equal to negative 7. So the two solutions to this quadratic are x equals positive 3 and x equals negative 7. And again, as I mentioned on the previous slide, the axis of symmetry then is halfway between these 2 points. So what you can actually do is 3 plus negative 7, which is negative 4, and then divide by 2. So the axis of symmetry is at the line x equals negative 2. Number 2, it's already factored for you. So we have our two factors. The first thing we're going to do is set this green factor x equal to 0. When we do that, you end up with, let's just do this again. Literally just x equals 0. Let's see. Sorry. I could write it, I guess. Or we could do it this way. There we go. X equals 0. And then the yellow factor, it's x minus 5. So when we solve that, we make x minus 5 equal to 0, which means that x would equal positive 5. I'll just do that. So the two solutions to this quadratic are at x equals 0 or x equals 5. And again, the axis of symmetry would be halfway between those 2 points. So 0 plus 5 is 5, divided by 2 is 2.5. If the quadratic is not already factored, you can use the magic factor box to factor it first, and then go ahead and follow the zero product property. Remember that you should have your quadratics in standard form, so ax squared plus bx plus c, and it should be set equal to 0 before you can do any factoring. For example, if we have x squared plus 7x plus 10, you could use magic factor box, but also since it's just x squared and not ax squared, you're basically just looking for the two numbers that add up to positive 10. That add up to positive 7, but multiply together to give you positive 10. And those two numbers obviously are 2 and 5. So the factored form of this quadratic is x plus 2 times x plus 5. It's still equal to 0. And then again, we just solve both of these equal to 0. So x plus 2 equals 0. And x plus 5 equals 0 would give us x is equal to negative 2. And then x is equal to negative 5, sorry. So negative 2, negative 5. If they asked you for the axis of symmetry, it would be halfway between these 2 points. So negative 2 plus negative 5 is negative 7 divided by 2. The axis of symmetry is at negative 3.5. One other example, x squared plus 2x equals 8. Again, this is just x squared, not ax squared, so you don't need to use the magic factor box. You can if you want, though. The problem, though, the thing that you need to do first is move this 8 over to the left. So the opposite of plus 8 is subtract 8 from both sides, and that leaves us with x squared plus 2x minus 8 equals 0. So we're looking for two numbers that add up to positive 2 but multiply together to give us negative 8. Those two numbers would be positive 4 and negative 2. Again, you could just quickly FOIL this to make sure you're correct. And then once you're sure you're correct, you set each of these two factors equal to 0 and solve for x. So x plus 4 equals 0 means that x is equal to negative 4. And then x minus 2 equals 0 means x is equal to positive 2. Again, axis of symmetry is halfway in between. Negative 4 plus 2 is negative 2, divided by 2 is negative 1. So the axis of symmetry of this parabola is at x equals negative 1. Just two more examples. X squared plus 2x plus 1 equals 0. Again, you can use magic factor box or just figure out two numbers that add up to positive 2 but multiply together to give you positive 1. In this case, they're both positive 1, so the factored form is x plus 1 times x plus 1. They are the same exact factors, so you only have to solve it once. So x plus 1 equals 0, which means that x is equal to negative 1. And that's the only solution to this parabola because it's the same factor twice. For number 6, we should use the magic factor box. If you can factor something out first, a GCF, do that. But in this case, there is no GCF. Remember, when we set up magic factor box, the ax squared and the c term go on the top, and then the 5x, in this case, the bx term, goes on the bottom right. And we're looking to factor down first. I'm going to have to fill this in slowly. There we go. So we have, one second, guys. Let's see. And there should be little numbers here. There we go. And there should be a 2 over here. Or 1. I'll just write it in. Okay, so when we're factoring going down, 12x squared, it could be 12x and x. It could be 2x and 6x. It could be 3x and 4x. I went with 4x and 3x here. And then the 2 can only be 2 and 1, so that makes it a little easier on us. Then what we're going to do is go straight across. 4x times 2 is 8x, 3x times 1 is 3x, and then trying to figure out if there's any way using positive and negatives to get 8x and 3x to turn out to be positive 5x, and there is. It would be the 8 is positive and the 3 is negative. Remember, you just transfer those signs straight over, and then the factors are the diagonals going, or the diagonals. So the two factors here are 4x minus 1 and 3x plus 2. And when you plug that in, you get 3x plus 2 is equal to 0. And then we have 4x minus 1 is equal to 0. So our two solutions would be x equals 1/4 or x equals negative 2/3. There are some quick checks for these problems as well, posted on the same form as 8-5. Do your best with them and let me know if you have any questions. Have a great day.